So let's talk about what technology-enhanced learning is. This is just a brief introduction to that concept and to the course. So broadly defined, technology-enhanced learning incorporates or covers a wide range of things. It's not restricted with respect to technology or different types of pedagogy. It can include both hardware, such as tablets, whiteboards, and other devices. It can also include software, such as games, game-based platforms that you can build TEL environments within. Learning management systems can be TEL applications. Different communications technologies can also be TELs. The example here to the left is Feedly, which is a RSS feed reader that can be utilized to create a personal learning network, something we're going to explore in this particular class. We're going to explore a number of these different TEL environments and TEL tools within this course, but the neat thing about this particular subject is that you can explore lots of different spaces and lots of different areas depending on your needs for training and learning. Adding to that definition, what we're really trying to do is improve the quality and outcomes of learning where technology has a significant role to play. So in order to do that, we end up seeing groups of researchers and groups of individuals coming together in interdisciplinary teams to accomplish these things. And I'm going to give an example here in just a minute of a project that I've been working on. But these teams become quite diverse, and there's lots of different skills that are brought to bear. So first we have to analyze the tasks that need to be done and design around those tasks. We have a significant piece on innovation and the management of that innovation process, curriculum design, assessment, development and design. We have environmental design issues. And then, more recently, we're starting to look at analytics. So what data trails can we collect surrounding these TELs, and how can we use those data trails to inform students, inform learners, to inform instructors? And there's research happening in all of these areas. So it's fun to explore, interesting to explore TEL as a graduate student and as a researcher. TEL designers are seeking to improve learning experience, learning outcomes. We're aiming at student engagement, increasing engagement of the learner, and the satisfaction and retention of those learners. We are looking to personalize the learning and promoting student reflection or learner reflection through the implementation of things like the testing and spacing effects, which are very well established within the cognitive psychology literature on learning. And we're also interested in collecting data streams for evidence-based assessments, which we'll discuss in this class. The example to the left is Quest Atlantis. It's a game-based learning experience where students explore different professions and learn through behavioral engagement. As I mentioned before, there's two major themes in this course. The first theme is the use of technology to create connections and networks for learning. So we're going to talk about and look at theory related to that, and we're going to explore how to create a personal learning network. And we're actually going to use those personal learning networks in this course to learn from each other. The second major theme is really about designing digital interventions, and here we want to explore theory, and we want to explore how to incorporate some of the best practices to design TELs and environments, TEL environments that help us enhance engagement and that help us help students retain the information that we're trying to deliver. So based on these major themes and based on where we're going in the course, I want to start off with an example. The example is the Cycles Carnival game, and it's a game that I was involved in designing and developing for learning and training surrounding cognitive biases. The Cycles Carnival game was developed as a research project through the Intelligence Advanced Research Project Activity, or IARPA, which is a research collaboration that crosses the intelligence communities. The program goal was to design games, serious games, that could be utilized to train intelligence agents to mitigate cognitive biases and to recognize those cognitive biases. The objective was really to experimentally manipulate variables within these TEL environments and then to collect data and evidence as to the impact of those manipulations on players' learning outcomes and learner engagement. There were 6 cognitive biases that are listed here that were of interest. I'm not going to go into each one of these at this point. We may talk about these further later on in the course. But really the concept and the thing that's interesting to, I think, students potentially in this class is that these cognitive biases are something that we bring to our decision making. Everybody has them. And we bring to the table when we're making decisions. And the only way to lessen the impact of these cognitive biases on our decision making and potentially poor decisions is to behave differently. So one of the things that IARPA was interested in is whether or not games could help players recognize these cognitive biases may be at play, and then encourage behavior in game that would help them mitigate the effects of these biases on their decisions. So it's the behavioral situated nature of games that IARPA was really interested in regards to training, and that opened up a whole line of inquiry about, okay, so can we design things in the game that get them to behave in different ways, and then what data can we collect surrounding that? So this technology enhanced learning activity is an interesting example of a design and build and research project that really highlights the significance and potential power of TELs. So we'll come back to this throughout the course. Just a little bit about our game, our Cycles game. We put in a proposal to IARPA that was funded. The research was funded for a 4-year term. We're actually still performing on this particular grant. We're 3 years in. We have 1 year to go. We have a large team, 3 universities which are listed there, and a gaming company called First Playable that's creating the game for us. We were one of 5 original proposals or funded teams, and there are 3 left. So each year we have a sort of go, no-go decision, and teams are eliminated. In experimentation, we are looking at relationships between the following variables. We looked at narrative, high-low narrative, visual abstraction or art, either high fidelity art or low fidelity art, character customization, which is whether or not the player can customize their character, and then we looked at rewards. So we gave players lots of rewards, or we gave them no rewards, but essentially. Player control, whether or not they could control the game. So in the image below, you can see that we implemented this sort of control mechanism where there's a map, and players can click on the different challenges, and they have control as to which bias to look at first, and how they progress through the game. And then we took away that control to see the difference in learning outcomes and engagement. We experimented with repetition, essentially spacing and testing effects, so either having those or not, and how that impacted learning. And then we introduced a SAT, which is a structural analytic technique, a special technique for mitigating cognitive biases. We're still in the process of learning about this one to see if it has an impact on learning. All the experiments that we ran with large numbers, so we could get decent data and decent outcome information. And then we used a control variable, which was a video condition that was created by a third party to teach basically the same thing. So we're trying to see if games outperformed that video condition. The top image here is a technology-enhanced learning environment that we created, within the carnival. And we like the carnival theme because cognitive biases are sort of these tricks that your mind plays. They're shortcuts that we use, and oftentimes we make poor decisions. So in this particular example here, you are in a game where you're trying to knock over the bottles with these objects. You get to choose which object you want to throw. And the bias at play is representativeness bias. If you simply select the bricks, which are on the right-hand side, and throw them because you think that they're going to be heavy and they'll knock over those pins better than the feathers, which are in the middle, then you are exhibiting representativeness bias. So we give them an opportunity to behave in not so optimal ways, and then we teach them how to behave differently. And the way to behave differently is to look for additional information in this case, which would give you the chances or the odds of these objects knocking over those bottles, which then they can reveal and then perform, improve their performance based on that base rate information. Some of the findings from our research, first of all, video games or TELs repeatedly outperformed video-based training in multiple experiments, particularly in relation to behavioral objectives. The immediate practical effect sizes were considered to be very promising. They were medium to large between experimental conditions, the video and the game. Based on these large effect sizes, this is very promising for training using the intervention of TELs. If you'd like to learn a little bit more about Cohen's d and effect sizes, I've placed a link within Canvas under the additional readings where you can go and explore this concept further. Furthermore, students were more highly engaged in the cycles game than the video condition. In this introduction to TEL, I simply wanted to show you an example, and in the cycles game show the promise that TEL environments have shown. I didn't give you all the details of the game or the experiment or the experimental condition and how that was run, but I simply want you to get the idea of the potential for such environments and the type of research that is taking place within these environments. So why study technology-enhanced learning? Well, hopefully I've piqued your interest a little bit with the example, the cycles example, in that there's great potential and promise for using technology to enhance learning and to enhance our teaching. Given that, these projects become very complex. They can become very large and they can become interdisciplinary in their structure. So we need some guidance and we need some frameworks that can provide us with some support. And we'll talk about these frameworks in this particular course. These efforts become very creative and often innovative in nature, so we'll discuss that a bit as well. So this course is really getting you to think about these opportunities, the opportunities that technology-enhanced learning provide, and it gives you an opportunity to explore some of these concepts and to apply some of the things we learned in the class. So welcome to the course again. Your first assignment has been posted. Your first assignment is to introduce yourself. So I will chat with everybody in the discussion area in Canvas.